Comp 2311 Systems Analysis and Design. Introduction to Information Systems and Systems Analysis and Design. Your module leader is Dr. Joy Garfield, and you also have Sherry O'Sullivan as a tutor. Learning outcomes for this specific session is really to introduce you or review what information systems mean to you, concepts of information systems, and to understand what systems analysis and design is and why it is needed. It's also to understand the role of the systems analyst and to identify and discuss key issues relating to systems analysis and design. This module is about systems analysis and design. But what actually is a system? Before we look into anything else, let's actually find some definitions of what a system is. Now, the word system is really from the Greek word for, and which meant a setting or placing together. So our first definition, and both of these are from the Oxford Dictionary, by the way, our first definition is a set of things working together as parts of a mechanism or an interconnecting network, a complex whole. That's actually systemic. Okay? So the components are working together to form a whole. The second definition is a set of principles or procedures according to which something is done, an organised scheme or method, and that's systematic, which means having a plan or a method. So in other words, a plan of action or a set of way of doing something, an organised procedure or method for doing something. Okay, we've looked at a basic definition from the Oxford Dictionary. Now let's look at a definition from systems engineering, really. So it's an integrated set of elements that accomplish a defined objective. That's from the International Council on Systems Engineering, INCOS, from 2000. In other words, a set of components interconnected for a purpose. Laszlo and Krippner define it as a complex of interacting components together with the relationships among them that permit the identification of a boundary maintaining entity or process. Okay, further definitions. And really, I love the idea of Chestnut in 1967 stating that the concept of a system is not a simple or unique one. There are many different kinds of systems, and different systems may be organised and operated in different ways. According to Ackoff in 1981, he states that a system is a set of two or more interrelated elements with the following properties. 1. Each element has an effect on the functioning of the whole. 2. Each element is affected by at least one other element in the system. 3. All possible subgroups of elements also have the first two properties. Okay, let's have a quick look at a model of a system. And basically we're looking really here at open systems, and the systems have input and output flows representing exchange. In our case, we're interested in the exchange of information with its surroundings. And the characteristics of a system really is that they have behaviour and they have structure, they have input-output, they have integration and functional and structural relationships. By the functional relationships, I mean it exists between the parts because there's flow and transfer of some type of information. Within the boundary, we have elements, attributes and relationships. So the characteristics are input and output, behaviour, structure, relationships and integration. And the properties within the boundaries are elements, attributes and relationship. It's quite a complex model for you to understand, so let's just quickly recap. The characteristics really, input, output, you all have heard about input-output flows, input of information, then something's processed and then you get an output. That's the normal explanation of information processing. The structure really, by that we mean it contains parts or components and they're related to each other. And the system, the behaviour, systems exhibit processes and either it will fulfil a function or purpose. In our instance, we're talking about the purpose of information. What is the point of the system? So, for instance, we may not think of them as having an objective, but there is a purpose. So they're made with a purpose that are achieved by the delivery of outputs. By integration, we mean that the parts and processes are really connected by structural, or it could also be behavioural relationships. And the structure and behaviour can be decomposed via subsystems and sub-processes to elementary parts and process steps. We actually simplify systems by making models. They're really simplified representations, so we can actually understand them, otherwise it'd be too complex. For instance, information systems interact with people, organisations and other systems. A simpler definition of systems from the model that we looked at earlier, from Stair and Reynolds in 2011, is a set of elements or components that interact to accomplish goals. The elements and relationships among them determine how the system works. Systems have inputs, processing mechanisms, outputs and feedback. So here you've got an example of an automatic car wash. So the input is the car going in, it gets processed by being washed, and then its output beautifully shiny. Okay, some quote by Laszlo and Krippner here, talking about Checkland, who developed the concept of, or classification of, hard and soft systems. Now, he really developed it to represent two ends of a continuum. So we have hard systems that really, in a way, are easier to define and they've more clear-cut aims or purpose. So it's things, real-world problem-solving things, machines, aircraft, so anything to do with engineering or to do with computerised systems. They have a simplicity, really, of purpose and clarity of boundary, but it doesn't necessarily mean that they're easier to design or operate or maintain. And they can be really highly complex. However, on the other extreme are the soft systems, because they're to do with human beings, and those systems are much more difficult to define. So those systems are things like improving health service, improving the education system, how to conduct a business in a more sustainable way. They're difficult because they may exist many different perspectives, values, and also which one is more important. Each stakeholder will have something that's important from their viewpoint, and that's why these systems are much harder to actually design than hard systems. Information systems. Again, I'm just going to take this from the Encyclopaedia Britannica. There are different things you can say about what information systems are, but if you think about it, it's an integrated set of components for collecting, storing and processing data, and for delivering information, knowledge and digital products. It's important to understand that information systems can be manual as well as computerised. In other words, it may be that they haven't computerised their information system, but they have a manual system. So the amount of people that say, actually, we haven't got a system. Oh yes, you have, because you're doing something in a particular way. Now, a better information systems definition is an information system is a group of interrelated components that work collectively to carry out input, processing, output, storage and control actions in order to convert data into information products that can be used to support forecasting, planning, control, coordination, decision making and operational activities in an organisation. Here we can see a representation of a system within a system, in a system basically. So we've got the website client side and then we've got the database server side. So they're both systems interacting with each other, and then that whole system interacts with the outside environment. So you input a flow, you input a query for instance, or you click a button and then you hope to receive something on the other side. So from the client side website you input, so you might input a query and then the response would be that it would do an output flow to the client side and then you would actually receive that. Another example of computer-based information system, and this is from Bode, Boonstra and Kennedy. So you can see here that you've got the external environment, you've got the input of data and the output of information, and then feedback, and inside the data being transformed and processed. Okay, let's take an overview of information systems. We're going to start with this so that you can get an overview of types of information systems that exist. And we're going to introduce you to Bob the Builder. I couldn't think of anybody else. I thought Bob the Builder was as good as any. There are many types of systems and many definitions for a system. For instance, the generic application systems, control systems, expert systems, games, and information systems. For our purpose, let us initially define an information system as the way a business functions in a particular area of an organisation. In other words, we're concerned about its business rules and processes, and it exists whether it's manual or computerised. Finally, let's look at it as having a boundary and external surroundings. We're going to use a simplified version, so modelling it a bit more simply than the one we looked at before. So if we do a square, system interacts with external entities. We have people, other systems and possibly organisations. Okay then, how does this concept relate to information systems? Let's have a look. We have input, so the system gets input from the entities, whether they are other systems or organisations. It transforms it within the system. So that's the process that it does. Then it outputs the result. Obviously this is a simplified version. Inputs can be stored and then transformed, manipulated or processed. So there you go. It can have it from organisations, other systems or people. Then eventually it outputs to an entity. Okay, let's meet Bob the Builder and find some systems. Hello Bob, tell me a little bit about your business. Sometime later, much later, because this step would take a long time. Once all the information is had, yes, that about sums it up. I have a small warehouse with building materials that need to be kept up to date. I have workmen who are subcontracted. And then, of course, I have the jobs that need fulfilling. So let's take each one at a time. So the system types. So small warehouse with building really is a stock control. It gets stock in, stock out. The processes that need to be done here, he needs to order when his stock is low. The entities that he needs to interact with would be the supplier, Okay, let's look at the next one. I have workmen who are subcontracted. That really is a booking allocation type of system. And for the processors, he needs to actually allocate workmen to the jobs. The entities that he needs to take into account are workmen and the client for the job. And jobs that need fulfilling, that's the actual booking. So he needs to initially book the jobs. So he needs to book his clients for a particular job. And the entities, again, are the client workmen. Now you may think that the booking allocation of the workman client and the client workman are exactly the same, but initially he's going to actually have to book in the client before he can book in the workman. And he's also going to have to think about, can I book that job then? Because I might not have the workman. So, though they may look as if they're actual same type of booking, it is something that he's going to have to do in 2 steps. How many types of systems are there in the world? I'm talking about information systems here. Now, most information systems actually derive from booking, allocation, reservation, scheduling, sales, purchase, and stock control, sometimes known as inventory. Usually this includes sales, purchase, or both. Though business rules may differ, each type of system can have many similar processes. There are some references and further reading, but I'm not going to go through it, but it'll be available on the PowerPoint version of this.